Here we go. 1-6. We are looking at polygons today. 2 CLTs. The first one, very simple. I can identify and name polygons. We are going to learn 2 types of polygons today. That's how we identify them. You will learn how to name a polygon today, so you'll be able to do the first CLT no problem. Second one, I can find perimeter of polygons. What is perimeter?
Around.
The distance around. Okay, so you're going to be able to find the perimeter of any polygon. What is a polygon? Let us find out. A polygon is a closed, be sure it's closed, figure whose sides are all segments. Closed figure, all segments. What's a segment? Huh?
Or a part of something.
A line that ends at both sides. I just couldn't hear you.
Sorry.
I didn't know what you were saying. Okay, so it is a line that ends at both sides. The sides are called sides. I don't know why they put that in the definition, but they do. And the vertex of each angle is a vertex of the polygon. And you'll see what I mean here in a second. Okay, all 3 of these shapes are polygons. Okay, they're all line segments. Take, for example, the triangle. All line segments. This one, kind of like an inverted triangle. All line segments. Once again, all line segments. The reason this one has letters on it is because I'm going to show you how to name your polygons, okay? You start with the lowest letter in the alphabet, and then you go alphabetically. So in this case, this is polygon A, B, C, D, E, F.
You have to start at a certain point or anywhere on the shape.
Start at the lowest letter.
No, not the letter. I mean the size of the shape of the corners. How you started on that top left corner. You have to start at A there.
You start at the lowest letter. If A was down here, then I'd start here. Go A, B, C, D. Just name it wherever your lowest letter is. Okay, so those are all polygons. We also have a set that are not known yet. So we're going to go through these things. Is this one a polygon?
No.
Why not?
Close.
It's not closed. It's missing this little piece right here. So it is not a polygon. Is that a polygon?
No.
Why not?
Curved lines.
Okay, polygons have to have line segments. These are not segments. Not a polygon. How about this one? Why not? Okay, the 2 lines intersect. If we separated these 2, yeah, they'd both be polygons, but together, they're not. All right, we have 2 types of polygons. The first one we're going to look at is concave. When I look at a concave polygon, I think of the word cave. I mean, if we have a mountain, a cave goes in. So if we have a polygon and somebody pushes in one of the sides, then it would be concave. When you push in a side, that makes a line pass through the middle of the polygon. So I'll show you 2 examples here. The first one, regular polygons are called convex. So there are 2 types of polygons. Convex, which means if you extend these line segments, none of them will go on the interior of the polygon. Concave, if you extend the line segments, they will hit the interior of the polygon. Convex, concave. Questions? So let's look at some names of polygons. On the left will be the number of sides. On the right will be what it is. So, three-sided polygon is called a what? A triangle. Okay? Tough one. You don't have to write these down. You should know most of them. Four sides. Or square. Five sides. Pentagon. Six sides.
Hexagon.
Hexagon. Seven. Heptagon. 8. 9. Nonagon. 10. 11. 12. Dodecagon. How about n number of sides? So however many sides there are after 12, we name it as just that number of sides and then a gon. So 100 would be 100 gon. 1,000 would be 1,000 gon. And whatever you got from there up. Same with 11. All right, like I said, first part of this is easy. Next we get into perimeter. Okay, so we're looking at three types of perimeters. The perimeter of a triangle, the perimeter of a square, and the perimeter of a rectangle. Triangle, P equals A plus B plus C. What is A, B, and C? The sides. So we're going to add up the sides of the triangle, and that gives us the perimeter. Why does why does square say 4S? Right. All the sides are the same. So instead of writing S plus S plus S plus S, we write 4S. Same with the rectangle. We have two sides are the same. So it's 2L plus 2W. When you're finished with that, I want you to work on the perimeter of this one. Do it in your head. Justin, how much homework you got for me? Excellent. What'd you do with all that stuff I sent home? Still at home? Oh.
Yeah.
I didn't get to geometry.
Oh, you didn't get to it.
Yeah, 236 and then I got to that.
Oh. How do we find the perimeter? Yeah?
You add them up and times it by 2.
You add them up and times it by 2. Is that right?
No.
How do you use the formula to find it?
You add
Which formula do we use?
2 plus 2W.
The rectangle. 2L plus 2W. What's 2 times 5.7?
11.
Okay, and then we have 2 times 3.8, and we get,
7.6.
add those together, and you get 19. 19 what? Meters. We hope.
What he said could work though too.
Yeah, I know. All right, 19 meters. Be sure you add whatever unit of measure it is. If there are no units of measure, like if the m's were taken off of this, what would we write here then? Units. Okay, we have to write something there. What if it's the area? What are we going to write here? Units squared. Volume?
Cube.
Units cubed. It is cubed to 3. Okay, so now they want us to find the perimeter of this triangle. What do we know about this triangle?
It's gonna be harder than normal.
What?
It's gonna be harder to figure out than normal.
How come?
It just is.
It's got coordinates.
It's got coordinates. What does that mean?
You gotta find out.
You have to find the distance. We can't count squares. We have to find the distance. So we need, I'll just call them x, y, and z. We have to find x, we have to find y, we have to find z.
Wait, why wouldn't it be A, B, and C?
Could be.
Well, you said that A, B, and C were the sides, so why wouldn't you use A, B, C versus going against what you told us?
Doesn't matter. You can use any letter you want. Hence the name variable.
Or I can use AX cubed.
Wow. Thank you. Okay, so how do we find the distance of this line right here? Of x. So what are we going to do? Distance, or I'll write x because now we know what it is. The square root. We have, what is that? -5 minus a -6 is what?
-11.
-5 minus a -6. 1.
Oh.
And then we have 1 minus a -8. You get 9. What's 1 squared?
1,
What's 9 squared?
81,
What's 1 plus 81?
82.
So x equals 82. Good job, Michael. Okay, y. We have -1 minus a -5. 4. Then we have 4 minus 1. What's 4 squared? Square root of what?
27 or 25.
25, which is? So y equals 5. Now all we have to do is find z. So we have -1 minus -6. You're struggling here. 5. -1 plus 6. Then we have 4 minus a -8.
4, so 8.
12. Whoa, squared. What's 5 squared?
25.
25. What's 12 squared?
44.
Add those together, I get the square root of 169, which is what?
13.
Now what? I know all the sides.
Add them all together.
We add them all together. 13 and 5 is
18.
18 plus radical 82. Somebody wants to do it on their calculator? Go ahead, let me know what it is. 18 plus the square root of 82. So I'm saying, what, 27 point, 27.1 units. Questions? Okay, one more. Buy your lonesomes. Give her a go.
Can you use any coordinate you want?
I'm
Can
gonna.
you like?
Stop.
Can you? How are you getting like them together?
What do you mean? I find the distance. So it's this one and this one will give me this. Then I go this one to this one will give me that.
Okay.
Then I take this one to this one and it'll give me that.
Okay.
This is -5, -4. This one is 3, -4. And this one's 3, 3. Go ahead, get going. I'll be around. See what I can see. I'm pretty sure you're not going to do that.
I said if I could.
Let's see.
No, you've got to.
Is there a certain order?
Nope. I would do it the easy way, but that's your choice. More rocks. All right, you should be done. How many of you are finished? Well, I can get 2 lines instantly.
I know this.
Notice the y coordinates on the bottom 2. What are they? -4 and -4. What's -4 minus -4? 0. So if I have one set that is 0, that means my other set has to be the answer. What's -5 minus 3? Or what's the difference between this point and this point? Count them up. 1, 2, 3, 4, 5, 6, 7, 8. That line is 8. Once again, we have a 3 on the x and a 3 on the x. So all we have to do is find the difference between -4 and 3. What's 3 minus -4?
7.
2 done. What's the easiest way to find the hypotenuse? Here, Mikey. C, A, and B. What's C?
64 plus 49 equals something.
Square root of 113.
Exactly.
What's the easy way to find that if you don't want to do... Mikey, how did you get 64 plus 49?
Squared 8 and squared 7.
Does this look familiar?
Pythagorean theorem.
Thank you, Mikey.
You're welcome.
Pythagorean theorem. If you have a right triangle, we have a squared plus b squared equals c squared. 64 plus 49 equals c squared. 113 equals c squared. Square root both sides. Those cancel. I'm left with c equals the square root of 113. Add them up. You get 15 plus the square root of 113. Whatever it is, units. Questions? If it's easy, let it be easy. Notice that these things are running vertical line here, horizontal line here. Let's count the squares. In your homework, you're going to have to graph one where you're going to be able to count the squares for some lines, and then other lines you're going to have to use the distance formula. So be sure you graph your homework. Okay, so page 49 and 50, 13 to 35 odd.